Hi, everybody. Happy Friday. Let me refresh. Okay. Oh, and we're here. Okay. All right. So let's see. Okay. So yeah, last time we finished 9.4, and then okay. Yes. Is it the new one? Let's see. Okay. Yes, so today we're going to talk about session 9.5. And then next week, you're going to have homework 7 and quiz 4. Questions for you. Do you want to postpone the quiz to Wednesday so you have more time to do the homework and quiz? Yes? Okay. So let's do that. And not the syllabus, but the schedule. Okay, schedule here. So we postpone the homework and quiz to Wednesday. Okay. All right. And then, okay, save. Save as PDF. And I'm gonna change the okay, and the quiz. So quiz 4, added the due date to be sorry. Added the due date to be Wednesday. Okay. And save. Okay, so the homework due date, you know, the homework due date doesn't really matter because you still can do your homework after its due date. But so I changed the quiz due date. Okay, so yes, because we still miss some students. So yeah, when they are all here, we can talk about the changing the policy to increase the homework percentage 10% and decrease the exam percentage 10%. And by the way, have you been doing your homework? Yes. And if you have any questions about your homework, feel free to come to see me. Okay. So yeah, I have plenty of office hours, and I have a table in front of my office. You can sit in the table and do your homework. When you have questions, just come inside and ask me. Okay. So 9.5 total differentials and approximations. So total differential of two variables. Let z be a function of x and y. Let dx and dy be real number. Then the total differential of z is dz equals partial derivative with respect to x times dx plus partial derivative with respect to y times dy. Okay, why is that? Do you remember in Cal 1, we have y is a function of one variable, and then we have the dy dx is the derivative. Yes, everybody, from Cal 1. And when you both sides multiply by dx, you get dy equals the derivative times dx. This is the differential form. The change of y is approximately equal to the derivative of x times change of x. This is in Cal 1. And now we have, like Cal 2, we have a function with two variables. But the idea is still similar. You have instead of derivative, you have partial derivatives. That's why you use the partial derivative with respect to x, and you multiply by dx. Plus the partial derivative with respect to y, and you multiply by dy. Is that okay, everybody? And notation. Change of x is dx, change of y is dy. The change of z is not bz. It's actually f of the final point. So this is the final point. minus f of the initial point. Is that okay, everybody? So if you want to draw the picture, okay, you have a surface like that, and let's say this is like x and y, right? And let's say we have another point. So this is like, let's say this is the x direction and this is the y direction, and then let's say this is a new point, and you have this is like change of x, and then that is like change of y. So then this point, the dz is this formula. The change of z is actually f of the new point minus f of the initial point. So the actual change of the height. Can you imagine, everybody? All right. And so dz is the total differential, which approximates the change in the function value. And the change of z is the actual change in the function value. So actual change, that's why f of the final point minus f of the initial point. You get the actual change of the function value. And approximations for small values of dx and dy, they're about the same. Okay? So dz and change of z, they're about the same if we have a small dx and dy. Okay, how do we solve the following example? So we have z is a function of x and y, and we want to find dz. Look at this formula. So we need all the first partial derivatives. Okay? So part A, what is fx? Okay, how about you take turns and tell me the answer? Play! What is the derivative with respect to x? Yes, 27x squared. Will, what's the derivative with respect to x? Yes, so minus 16xy. And Sarah, what's the derivative of 4y squared? Or cubed? 0, yes. All right, this is the partial derivative with respect to x. How about partial derivative with respect to y? Stephanie, what's the derivative of 9x cubed? 0, right? Okay, good. And Gabby, Gabby, what's the derivative with respect to y? 8x squared, yes. And Paige, what's the derivative of 4y cubed? Yes. Okay, so we find all the first partial derivatives. Thanks, everybody. And let's see. Okay, now we gonna so we then plug into the formula. We get dz is the partial derivative with respect to x, which is 27x squared minus 16xy. Right here, fx dx. So dx, and then plus fy, which is negative ax squared plus 12y squared times dy. That's it. Fx dx plus fy dy. Okay, just compute the first partial derivatives. Okay, this is part A. Part B, we're gonna plug in numbers. Evaluate dz when x is 1 and y is 3. Dx is 0.01. dy is negative 0.02. So dz is 27. What is x? 1. What is 1 square? 1. Minus 16. X is 1. How about y? 3. What's the x? 0.01. And then plus negative 8. X is 1. And then the y is 3. What is 3 square? 3. Oh, yeah. 3 square. 9. Yes. And dy? Negative 0.02. Everybody? So let's see. Put this in your calculator. So parentheses 27 minus 16 times 3 times 0.01 plus negative a plus 12 times 9 times negative 0.02. Yeah. Put this in your calculator. What do you get? Can you type like everything in one line? Negative 2.209. Do you have the same answer? Kind of? Oh. Oh, okay. 2.21. Oh, so, okay, I see. Maybe a little bit? Okay, so good. So that is example 1. Example 2. Okay, we're gonna have z is a different function, and we want to find dz and the change of z and the absolute error. Okay, let's do that. So part A, we want to find the derivative with respect to x. And that is, you see L and U, right? We're going to use chain rule. What's the derivative of L and U? Yeah, it's 1 over U times U prime. Right, everybody? So 1 over U, what is U? 5. Yeah, and we multiply by U prime. Everybody? So 1 over U times U prime. But this prime is respect to x. Yes. Okay. So then the can we put them together? Can I put this on the top? Oh, by the way, what's the derivative with respect to x? Tan x. The y-cube derivative with respect to x? 0. Yes. So y is like a number. We get 10x over 5x squared plus y cube. Is that okay, everybody? Let's continue. Okay, this is fx. How about fy? Do you see the first step is the same, the 1 over u times u prime, but this prime is with respect to y. Okay, so let's write it down. 1 over u times u prime, but this prime is with respect to y. Okay, and now what is the derivative with respect to y? Yeah, 3y squared, yes. 3y squared, and we still have 5x squared plus y cubed. Yes, everybody? So dz, by the way, here, because we have the xy and dx dy, the dz is not a function anymore, it's not a number. They want you to plug in all the number and find the dz as a number. Okay? So dz, we know fx dx plus fy dy, but fx, let's also plug in the number. So 10x, what is x? 2. And then denominator 5x squared is 4. Y, what is y? 3, what's 3 cubed? 27. Good. So this is fx. Times dx. What is dx? 0.02. Yes. Plus fy. Fy is 3y squared. What is y squared? 9. Good. And the denominator. Do you see the denominator is the same as before? Oh, by the way, what's 5 times 4? 20 plus 27? 47. Good. Yes. And what's dy? Yes. Good. So let's simplify. We get 20 over 47 times 0.02 and plus, what is 3 times 9? 27 over 47 times negative 0.03. Yep, put this in your calculator. What do you get? Yeah, give me as many digits as your calculator displays. Wow, your calculator really give you a very long digits. How about other people's calculator? What do you use though? Second floor here. Okay. So yeah, in the exam, you just your calculator will show you up to here. Yeah. Okay, good. So let's see. Like for this kind of problems, I won't tell you like how many digits you need because it really depends on the problem. Because if I say round to 2 decimal, if you just get 0, that's not good, right? So I would say you write as many digits as your calculator. And you have your standard calculator, right? In exam, yeah. Okay, good. So that is part A. Part B, change of z. A change of z is actually f of the final point minus f of the initial point. Okay, everybody? The final point. Look at your x. What is your x? It is 2, but then your final point is like x plus change of x and your y plus change of y. You agree? So your x is 2. And 2 plus change of x? 0.02. Yep. And how about the y? Is 3. And then plus change of y? Oh, negative, right? 0.03. The x is 2. The change of x, 0.02. Y is 3. Change of y, negative 0.03. This is the final point. How about the initial point? Your initial point, xy, what is that? Yeah, 2 and 3, right. Okay, let's see. We combine them. So this is a 2.02. What is 3 minus 0.03? 2.97. Yes. Okay, minus f of 2, 3. All right. Now, when you compute change of z, you don't touch the derivative at all. You just look at the original function. Plug the points into the original function. So let's see. ln 5x. So x is 2.02 squared. We're plugging x is 2.02 squared and plus y is 2.97 cube. Right, everybody? And this is f of 2.02 comma 2.97 minus f of 2.3. So plugging your atom again, x is 2. So 5 times, what is 2 squared? 4. Plus y is 3. 3 cubed. 27, yeah. 27. Okay, good. And we know 5 times 4 plus 27 is 47. Good. Yeah, put this in your calculator and give me as many digits as you can. ln 5 times 2.02 squared plus 2.93 cubed parentheses minus ln 47. Oh, how many zero? 0.00. Mm-hmm. Okay, I see. I just want to say about it. So. Yeah. Okay. Everybody, you have the same answer? Good. Good. So, do you see they're close to each other? That makes sense. If one is like that, the other one is 1.45, then you know there's something wrong in the calculation. They should be close. Okay, now let's look at the absolute error. So absolute error, do you see it's the absolute value? So it's always positive. And I always look at which one is bigger. I use the bigger number minus the smaller number. Or in your calculator, you just one minus one. If you get negative, just get rid of the minus sign. Mm-hmm. So you get absolute error. Use one of the number. So can I just put arrows here? Instead of copying down the long digit again, just put arrows. Okay, this minus that. What did you get? You mean positive? Yeah, positive. Thank you. Yes, everybody? That's it. So this is the process of the total differential. We can use a differential to approximate the change, and you can compute the both and see the error parts. Okay. Any questions about this problem? Okay. So you see dz, we need to take the first partial derivative. The change of z, do you need to take the derivative? No, just the function put into the original function. Okay. So now, how about we have a function of three variables? So then you have fx dx plus fy dy plus fz dz. Okay, just extend one more dimension. But everything works similar. Okay. Now, yeah, let's do it together, and you tell me the answer one by one. So part A, let's find fx first. Hey, Wang. Yes, derivative with respect to x. Look at the first term. What is that? Yes, derivative of x is 1, and then the other just constant multiple. Leave it there. And the derivative of 3y is 0. Yes. Right, everybody? Okay, good. How about fy? Will. Derivative with respect to y. Do we need to do product rule here? No, because x is like a number, right? You leave the x here, constant multiple, and then this is like u. What's the derivative of L and u? Yeah, 1 over u, but u is yz times u prime. But this is just the first term. 1 over 1. Oh, y prime. The derivative of y is 1. And you still have the z. Yeah. And the derivative of negative 3y is negative 3. Yes. Okay, so because this part, the yz prime is z. Yes, because the derivative of y is 1. Z is constant multiple. It stays here. And what happens with the z? They cancel. So we have x. Yeah. X over y minus 3. Right, everybody? Okay. We still need fz. Okay, so yes. Yes. Oh, and we can cancel the y. We get x over z. Everybody? So you have to, every step, slow down. What is the variable? What is the constant? Even though, see, this expression are the same, but this prime is the derivative with respect to y, this prime is the derivative with respect to z. That's why the next step is different. Okay, good. Now we have the dw is fx dx plus fy dy plus fz dz. Is it easy to memorize? Yeah, fx dx plus fy dy plus fz dz. Okay, we fx, and we have the points. See? fx, lf, y, z. What is y? Y is plugging the numbers. Y is what is y? 1. And what is z? 4. Yes. This is fx. We're plugging y and z. And then what is dx? Yes. And then fy. Oh, when you compute this, make sure you put a parenthesis because it's the whole thing you multiply by 1. Okay? So whose parentheses? Your baby. Yes. Don't forget your baby. That's wrong. Okay. So what is x? 2. And what is the y? 1. Ooh, okay. What is dy? Yes. Okay, good. And then fz. Fz is x over z. So what is x? 2 over 4. dz. Yes. By the way, a change of x is x. Change of y is y. Change of z in this case is dz. But the dw and change of w are different. Okay, everybody? Put this in your calculator. So you get ln4 times 0.03, and then 2 minus 3 is -1, and then 2 over 4 is 1/2. So it's 1/2 times 0.05. Okay, you can simplify it. Then plug in your calculator. What do you get? Good different answer. Do you have different? Okay. Oh, I see. Yeah. Okay, good. So, other people, you get the same answer? Okay. So this is dw. Okay. Now part B, change of w is f of the final point. Can I just use PT stand for point? Minus f of the initial point. Okay, final point. What's the x? You're using the number 2 plus the change, which is 0.03. Is that okay, everybody? The final point is the x value plus the change. And then how about the y coordinates? What is that? Yes. How about the z? 4? Yes. So that is the final point. So what is your initial point? X is 2, y 1, z 4. Yes. Good. So then we're gonna plug in the function f. We're plug in the derivative. No. Look at the original function. By the way, this is 2.03. This is 1.02. How about the last one? Yes, good. Okay, now let's plug in. X. What is X? Yes, 2.03 times ln y is 1.02 z 3.95 minus 3y 1.02. That is the f of the final point. The minus f of the initial point. Make sure you put a parentheses there, because you have like two terms. If you have more than one term, you need the parentheses, because you would need to flip the sign if you forget the parentheses. Okay, so what is x? X is 2, and ln y is 1, z is 4, minus 3 times 1. Right? Everybody? In the function. And x is 2, y is 1, z is 4. And what do you get? Like that? Alright. And yeah, which is nice because they are close to each other. And we know they do. Okay, part C, the absolute error. The difference of them. So I can use like one number and subtract the second number. So yeah, in your calculator, can you go up to that number and enter, and then subtract, go up to the previous line and enter? And what is the difference? What is the difference? You have oh, here? Oh, there? Yeah. Oh. How about Sarah? Do you get an answer? Thank you. Yes. So that is the absolute error. Do you see the process is still similar to last example, but just now we have one more dimension. Yeah. And so your homework, yeah, have like different problems, and it's similar to that. You're gonna compute the dz and change of z, or if you have function of three variables, you compute the dw and the change of w, and then the error is the difference of them. Okay. All right. Now let's see application problem. Application problem. A portion of a blood vessel is measured as having the length of 7.9 centimeters and radius 0.8 centimeters. if each measurement could be off by as much as 0.05 centimeters. Estimates the maximum possible error in calculating the volume of the vessel. So we have what's the picture? Like a circular cylinder. Do you agree? Mm-hmm. And then cylinder, you care about the radius and the height. The radius and the height. Do you still remember the formula of volume of a cylinder? Volume is. Do you still remember? Okay, area of base times height. What is the area of the base? What's area of a circle? Yeah, pi r square, right? Pi r square. And the height is h. Right, everybody? So this is a function of two variables. Yep, everybody? Now the problem says, okay, it has the length. Oh, what was the length? This is like the h, right? The h is 7.9. The radius is 0.8. And if each of the measurement can be of as much as, so your dh is 0.05 and your dr is 0.05. Everybody? So it's asking what is the possible error in calculating this. All right. So let's do that. We have here so v is the function, right? We have two variable r and h. What's the partial derivative with respect to r? Are you okay with this notation? There's a variable, means you have the function and the partial derivative with respect to r here. Okay, what's the derivative with respect to r? 2. So pi and h are just constant multiple states. The derivative of r squared is 2r. Yeah, very good. So we got pi times 2r times h. Yes, everybody? Mm-hmm. Good. How about VH? Derivative is better. What? Yeah, pi r squared. Good. Okay, now let's see. dV is then VR times dr plus VH times dH. Are you okay with this expression? Mm-hmm. Yeah, it's the same like dz is mx dx plus fy. Okay. We are. Okay, what is we are? So put it here. Pi 2. What is r? 0.8. Yes, everybody? How about h? 7.9. Is that okay, everybody? We're running the numbers. This is VR. What is VR? Point 0.05. Yep. Plus VH. Pi r squared. What is r? You mean 0.8? Yeah, 0.8 squared. And dh. What is dh? 0.05. Good. Put this in your calculator. What do you get? Sorry, 2.086. Like that? Okay, thank you. Okay, so this is the maximum possible error in calculating the volume of the vessel. What that really means, if you calculate the volume, you know is pi r squared h, and then your r is what, like 0.8 squared, your h is like 7.9, right, everybody? Okay, could you put this in your calculator, and what do you get? Give me like 4 decimal places. Mm-hmm. Did you multiply by 7.9? And you get oh, 0.8, not 0.0. Oh. Yes. So what do you get? 15.4 decimal places. Thank you. So this is the volume, okay? And then your error is plus or minus the 2.86, 2.0860. Okay, so this is the calculated volume, and this one is the error. Okay, so you can kind of know this is our answer, but it might be off by 2. What's the units? If the length is centimeter, what's the units of the volume? Cube is centimeters. So this is what it means. Okay, you get an answer, but what is the error? How accurate it is? So this is the answer. Okay? And good. We finished 9.5 in one lecture. Yay! So next week you print out session 9.6. Okay? And yes, over the weekend, catch up on the old homework and then do the new homework, the 9.3 and 9.4. Mm-hmm. And you can also do 9.5 as well. And yes, I will be in my office from now till 1:50 and also 3:10 to 5. Feel free to come to see me and do your homework together. Mm-hmm. Bye.